Okay, so welcome to this video where we'll be doing the June 2024 mechanics paper. Let's go. So question one, we have this figure one here. It shows a particle P of mass 0.5 kilograms at rest on a rough horizontal plane. And we need to find the magnitude of the normal reaction of the plane on P. So if I just draw a little sketch here, okay? Then what do we have? Well, we have the particle P here, okay? And we know that that's going to have a mass of 0.5 kilograms, so that's a weight of 0.5 g newtons, okay? I'll just go over here. And then we find the magnitude of the normal reaction of the P at plane. Well, the normal reaction on the plane, that'll be perpendicular to the plane in the upwards direction. So that would just be this value here. So very easy. If we were to resolve forces, therefore, that would just give us that R is equal to a 0.5 g newtons. Okay, that is part A. Now, with part B, we are told that the coefficient of friction between P and the plane is 2/7, and we know there's a horizontal force of magnitude x newtons is applied to P. Given that P is now in limiting equilibrium, we need to find the value of x. Well, now we can add on this extra information. So we know there's a horizontal force of x newtons, so I'll draw it this way here. So this is x newtons. And then because it's a rough plane, we also know there's going to be friction in the opposing direction, okay? So because we're in limited equilibrium, our horizontal forces and our vertical forces must all be balanced. So at the moment, we have no forces going to the left, therefore our frictional force has to be going to the left, and let's call that F newtons. So now we are told that the coefficient of friction is 2/7. So what does that tell us? Well, we know the formula for friction is the coefficient of friction times the normal reaction, okay? So in our case, if we want to work out, what we can do is if we can work out the friction, then that should be the exact same as the x newtons because everything's in equilibrium. So let's work out the friction. And if we look at the friction, well, the friction would just be, it would be F, and that's equal to mu, which is 2/7, times by R, which we worked out in a previous question. That was 0.5 g. So I'll write that as a half g for now. And now, because we know that, we just need to work this out. So that means that F is going to be a 2/14g, which simplifies down to a 1/7 g newtons. And if we know that, well, we know that if we was to resolve forces horizontally, okay, that means that X would equal F. Therefore, X would also be 1/7 g newtons. And if you want to work that value out on your calculator, feel free to do it. So 1/7 times by 9.8, and that will give you 1.4 newtons. So for question two, we have this speed time graph, shows the model of a motion of an athlete running a 200-meter race in 24 seconds. And we'll be given all this information here. And the first question is we need to find the acceleration of the athlete during the first 4 seconds of the race, okay? The first 4 seconds, that would just be this bit here, okay? That's the first 4 seconds. As you can see, it's like a linear, it's a straight line, right? Linear line. So we can just use, we can just do, what's it called, change in y over change in x to work this out. So we know that we are 10 units up, okay? We know that this distance here, the vertical, that's 10 units up. We know that this thing here, that's 4 units. Therefore, for that first bit, for part A, fairly simple, it would just be 10/4, which gives us a 2.5 meters per second, okay? Remember that because we've got a speed time graph here, if you work out the gradient, okay, that would be your acceleration, okay? So just work out the gradient in that first 4 seconds. It's a straight line. It's like a linear line, so just need to do 10/4, change in y, change in x. 10 divided by 4 gives us 2.5 meters per second. Now, for part B, okay, we need to find the distance covered by the athlete during the first 18 seconds of the race, okay? First 18 seconds, so that is all of this, okay? It's a bad drawing, but yeah, we need to do all of this. So we need to find the distance during the first 18 seconds of the race. So how can we do that? Well, if we want the distance, well, the distance is just going to be the area under the graph, okay, it's just going to be the area under this speed time graph. So what we can do is we can work out the area of this triangle first. So this is during the first 4 seconds. Look at the area during the first 4 seconds. That's a triangle. And then, well, between 4 and 18, we have this rectangle here. So therefore, we can just work out the area of that rectangle, just add them up together, and that should give us the distance. Okay, so let's do that. So what I'm going to do, I'm just going to draw that triangle now. Okay, so what do we know about the triangle? Well, we know with the triangle, we know that it is 10 units up and it's 4 units across. Okay, so for the triangle, to look at the area, it's very simple, just half times base times height. So that would be a half times 4 times 10. That gives us 20, okay? So now the area of the triangle is 20. And now if we want to work out the area of the rectangle, okay? The area here of this rectangle, well then let's just scroll back. So we know that the area of the rectangle, we know this can be 14 units across, okay, because it's between 4 and 18, that's 14 units across, and it will still be 10 units up, okay? So therefore, for this rectangle, it's 14 across, 10 up. Area of a rectangle is 14 times 10, that's equal to 140. So therefore, we know this is 140. Then we just add them up together. So we do a 140 plus 20, and that will give us 160 meters. So we know that the distance between the first 18 seconds is 160 meters. Okay, so for part C, we need to find the value of u. So to find the value of u, okay, u is this speed here, and u is the speed that the athlete finishes with, right? So they finish with speed u, okay? So we know that it's like this distance here, this is them finishing with u speed, okay? So how can we work this out? Well, what we can do is we know from a previous question, we just worked out, if I use this color here, we just worked out that we know the distance from the first 18 seconds, okay? We know that from the first 18 seconds from part B, we know that the distance traveled is 160 meters, okay? So we know that this distance here is 160 meters, which means that it's a 200 meter race, which means that from 18 to 24 seconds, that must be the extra 40 meters, right? Because it's 200 meters in total. And we know that the rider finishes at U. So they finish at this point here. So, but what else do we know? Well, we know that if they finish at that point, we also know that from 18 to 24 seconds, okay, from 18 to 24 seconds, that must be a distance of 40 meters. And they finish at this point here. They finish at U. So we can use this information now to actually work out a value of U with this information. So what we can do, if I just change my color now, well, what do we know? Well, we know that if all we now need to do is work out this area between 18 and 24 seconds, and if we look at that area, we know that area must equal 40 meters. So let's work that out. Okay, so if we want to work out that area between 18 and 24, well then, what do we know? Well, if we break this up into 2 parts, okay, let's break this up into 2 parts. So if I get rid of this 40 meters now, let's break this up into 2 parts. We know that if let's look at the area of the triangle first, okay? So if we do the area of the triangle first, if I just use this one here, look at the area of that triangle first. Well, the area of the triangle, we know that if this whole distance, okay, we know that this whole distance here is 10 meters, okay? 10 meters per second. So what we can do, and we know this is u, well then if we just want the area of just that triangle, it would just be, okay, 10 minus u. So for the triangle, we know that it's 10 minus u, okay? And then and we go across, we know that that is also going to be a 6, okay? So we know that the area of a triangle is a half times base times height, okay? So if we do that now, let's do this up here. We know that the area of the triangle would just be a half, okay, times that 10 minus u, okay, and times that 6. If we work that all out, what does that give us? Well, that will give us a 10 minus u, which will be a 30 minus a 3u. So what does that tell us? that tells us that this area of this triangle is a 30 minus a 3u. Now we just need to work out the area of the rectangle. Well, the area of the rectangle, well, we know this is going to be u up. Okay, this is just u up. So therefore, we know that that's a 6 times u, so that's just going to be a 6u here. So therefore, we have the 6u, let me just make it a little more consistent, and we also have the 30 minus the 3u. And we know that that has to equal 40 meters. Therefore, if it has to equal 40 meters, it would just simply be a 30 minus 3u plus the 6u, and that must equal 40. Therefore, what do we get? Well, if we bring the 30 to the side and we simplify this down, we get a 3u is equal to a 10. Therefore, we get a u is equal to a 10 over 3. Okay, so for question 3, we have a particle P of mass m. It's held at rest at a point on a rough horizontal plane, as shown in figure 3. It's given that the plane is inclined to the horizontal alpha, where tan alpha is 5 over 12. Coefficient of friction between P and the plane is mu, where mu is less than 5 over 12. Particle P is released from rest and slides down the plane. So first things first, we need to find in terms of m and g the magnitude of the normal reaction on the plane at P. Okay, so let's go through everything we've been given here. So I've just drawn it down here. So we've got this particle, let's say P is here. Okay, now we are told that it has a mass m. So we know that it has a mass of weight of mg newtons. Okay. We are told that it slides down the plane. Okay, so it releases from rest and slides down the plane. So therefore, our acceleration or our velocity, so acceleration is a meters per second. Okay, it slides down the plane. Therefore, we're also told that there's friction. Well, if there's friction, friction works in the opposite direction of motion. So therefore, friction will be acting up the plane. So we know that that is F newtons. We're also going to have a reaction to the plane, so perpendicular to the plane. So that will be in this direction here. Okay, so that would be the normal reaction. Any information else we've been given, we are told that it is an angle alpha to the horizontal. So we know that this is alpha here. And we're told that a tan, let me say this is A, we're told that a tan alpha is equal to a 5 over 12. So if we think about that, draw a little right angle triangle here. Okay, therefore, this is 5, this is 12, this will be 13. Therefore, we also know that sine alpha would be opposite over hypotenuse, so that would be a 5 over 13. And cos alpha would be a 12 over 13. Okay, so we've used all the information we've been given. And then we need to work out, the first question is, in terms of m and g, find the normal reaction on the plane at P. So we need to find that R newtons. So how can we look at that R newtons? Okay, well, if I just draw in this angle here, we know this angle must be a sine alpha, okay? And we know that if I draw a dotted line here, we know that this will also just be an alpha. Therefore, to work out our R newtons, all we need to do is just resolve in the same direction as R. So if we resolve in the same direction as R, okay, therefore that'll just be R is equal to an mg cosine alpha. Okay, there is no and also we don't need to worry about F equals ma because we're doing perpendicular to the direction of motion, so there is no motion. Therefore, it's just R is equal to mg cosine alpha, and we know cosine alpha is 12 over 13. Therefore, R is simply just a 12 over 13 mg. Now, part B, we need to show that as P slides down the plane, the acceleration of P down the plane is 1 over 13 g, 5 minus 12 mu. So let's start with resolving this. Okay, so we need to find an expression for the acceleration. So we know acceleration is going down the plane. So if let's do this on this side here. If we know we're sliding down the plane, well, then what does that really mean? Well, if we're sliding down the plane, then if we resolve forces in that direction of sliding down the plane, well, the only force we have in that direction is the mg. So it'll be mg sine alpha, okay? and that would just be minus the friction. Okay, friction's already in that same direction, and that would equal ma. Well, we know ma is just going to be ma in this case. Okay, so we've got mg sine alpha minus f is equal to ma. Well, we know sine alpha from the previous question, we know that's 5 over 13. Therefore, for this question, we can change that so far. So we can change it to a 5 over 13 mg. And with the f, well, with the f, we know that we want it in terms of mu. And we know that, if I write it here, f is equal to mu r. So we can just change that f into mu r. So by doing that, that would change to, it'll be a minus mu, and we worked out normal reaction in the previous question. That would just be a 12 over 13 mg, okay? And that is equal to ma. Okay, so now that we've done all that, we've done all the hard work, now we need to rearrange this and get A as to be the subject of the formula. So to do that, very, very simple. Before we do that, we can, first things first, we can cancel out all our m's, okay? Because m is in every single term, so we can just cancel out all of our m's. That's the first thing. So now we're left with 5 over 13g minus a 12 over 13 mu g, okay? And that's equal to A. So it's taken shape now. We've got an expression for A, and now we just need to configure it and put it into the exact form we want. So fairly simple to do that. If we've got it in this form here, okay, all we need to do to work out to get it in that same form is, well, what we can do is we can just take out the factor of 1 over 13g, because 1 over 13g is a factor in both of them. So we take out 1 over 13g, and then we're just left with 5 minus a 12 mu, and that is exactly in the form which they want it. So for part C, we need to state what would happen if P is released from rest, but mu is still greater than or equal to 5 over 12. So for this question here, well, we know that mu is less than 5 over 12. But if mu was greater than or equal to 5 over 12, well, then what does that mean for our question here? What that means is effectively, if mu was greater than 5 over 12, the friction would be actually greater than the downwards force or the weight. It would be greater than that weight, and therefore, if it was greater than 5 over 12, what that would mean is, if you try and release it from rest, it would just stay at rest, okay? Because the coefficient of friction is greater than 5 over 12 now. So if you try and release it from rest, it would just stay at rest, okay? So all you need to put is that P would stay at rest, okay? For P, what in this question, mu needs to be less than 5 over 12 for it to move when it's released at rest. In this case, if mu is greater than 5 over 12, the friction would be greater than the weight going down the plane, right? It'll be greater, therefore the friction, therefore it would just still stay at rest, okay? So just put something like P would stay at rest. So for question 4, we have got the specific vector of a particle P is r meters, where r is equals to that equation there, where c is a constant, and when t is equal to 4, the bearing of P from O is 135 degrees. Show that c is equal to 3. Okay, well, first things first, we're told that when t is equal to 4, we have the bearing of P from O is 135. So let's put 4 into t in the equation. So therefore, what does that give us? So we get an r is equal to a c, and then we get a 1 over 2 I minus a 3 over 8 4 squared j. So if we work that out, we get r is equal to square root of 4, that's a 2ci, and then this one would be a minus 3 over 8, so let me just do a minus 3 over 8, that would be a 16, that would be a j, and that goes to a 2ci, and then that would give me a minus 3 times 16 is a 48, and then over 8 is a minus 6j. So now that at t is equal to 4, we know the position vector now is going to be a 2ci and a minus 6j. And the question, they tell us that it has a bearing of 135. So if we wish to think about the bearing, if we wish to draw the bearing here, okay, then what does that look like? Well, so we do just a bit longer here. So if we do the bearing now, that would be, so bearing always starts north and goes clockwise. So it'll be something like this, and it would stop about here, right? because that would be 135. It wouldn't touch back the line, that would be 180. And what do we know about this line here? Well, if I just draw this line here, okay? So what do we know about that? Well, we know that we actually know what this angle is in between, okay? We know what this angle is here in between. We know that from the horizontal, we know that this angle is going to be 45 degrees, right? So if we know that with this new position vector of P, when it's at 4 seconds, it's going to be in this direction, the same direction as the orange line. That is going to be the direction of this new position vector. So if we know that, well, we can actually just draw a triangle. So if we draw like a right angled triangle here, so like this, and then it goes down like this, and like this, okay? So we've drawn a right angled triangle. What do we know about this? Well, we know that from what we just worked out, we know that it would be 2ci minus 6j. So we know that this would be a 2c here, and this would be a 6 here, which makes perfect sense if you look at the bearing. Now, we also know that this angle here, the angle to the horizontal, we know that that is 45, right, due to the bearing. And if we know that, we want to work out, prove that C is 3. Well, we can prove that C is 3, okay? From just using trigonometry, we can prove that C is 3 from using SOHCAHTOA. Because if you think about it, okay, if we label these, this is like the hypotenuse, this would be the opposite, and then this is the adjacent. We can just use simple SOHCAHTOA to prove that C is 3. So therefore, in this case, we have opposite and adjacent, so it's just simply going to be that tan 45 is equal to opposite, which is 6, over adjacent, which is 2c. Tan 45 is just 1, so you put in the calculator, you will get a 1. So therefore, we have that a 1 is equal to a 6 over 2c. Then 1 is equal to, you can cancel the 6 and the 2, that'll be a 3 over c. And therefore, by looking at that, you can clearly see that c must equal 3. Okay, so for part B, we need to find out the speed of P when t is equal to 4. So first things first, if we rewrite this equation now, so we have this equation for R, if we just rewrite this, but now we rewrite it knowing what C is now. So if I rewrite this over here, that would be a R is equal to a 3t to the half I, okay? That's minus a 3 over 8 t squared j. Now we'll look at the speed of P, okay? Now we've been given the position vector of P, okay? So in this case, this is like a variable acceleration, you can kind of think of it. In order to work out what our speed is, we need to differentiate this, because if we differentiate this, this is like the distance or the displacement, how you want to think about it. If we work this out, okay, if we differentiate it, that will give us the velocity. And then through there, we can choose Pythagoras theorem, and that will give us the speed. So the first thing first, let's differentiate this, okay? So we know that v would equal dr over dt in this case. So if we were to work this out, differentiating that, we would get a 3 over 2 t to the minus a half, okay? And that would be our I still. And then this one, we would get a minus 3 over 8 times a 2 is a minus 6 over 8, which simplifies down to a minus 3 over 4. And that would just simply be a t, okay? And that would be a j. Okay, and now what we can do is we can substitute in that 4, because we want the speed when it's at 4. So if we substitute in 4, we get a 3 over 2, 4 to the minus negative a half. And that would still be our I here, and that's a minus 3 over 4 to the 4, and that would be a j here. And if we work this out, we'll get a 3 over 2 times, we do it with this one here, it'd be a half, because you do the reciprocal, so you get 1 over 4, and then you square root 1 over 4, you get a half, and that would still be I. And then minus a 3 over 4, just 4 here, I see them in one go, that one would just simply be a minus a 3j. And therefore, if we simplify this down, we'd get a 3 over 4, so we get a 3 over 4i minus a 3j. So we know that velocity is 3 over 4i minus 3j when t is 4, and we want to work out the speed, so now we need to use Pythagoras' theorem to work that out. So we use Pythagoras' theorem, that would be a 3 over 4 squared plus 3, obviously should be minus, but it doesn't make a difference. And then that is all just going to be square rooted, okay? And now with this question, it does say I want us to show all of our workings. So for this one, well, we want to just print our calculator. It's probably best maybe just to show all the workings fully. So for this one, we would get the square root of 3 over 4 squared is a 9 over 16 plus a 9, okay? And then, well, what can we do with this? Well, we have 9 over 16. So what we can do is we can also put everything over the same fraction, okay? So we have 9 over 16, and we need to times that 16 by 9. So times that 16 by 9, that will give us a 144 over 16. And therefore, that will give us a square root of 153 over 16. And then if we simplify this down, that means we get a square root of 153 over the square root of 16. Well, 153 looks like a weird number, right? It doesn't look like a normal number, but actually, it actually does simplify it down, okay? Because if you think about it, if you look at the previous question, right, we did 9 times by 16, right? And we got 144. So now at 153, that's effectively like we just added another 9, which is effectively the same as saying 9 times 17. So 9 times 17 is 153. Therefore, we get a root 9 over here times by root 17. And then that's just going to be over a 4. And then that simplifies down. So we are left with 3 root 17 over 4. And that would be meters per second. So for part C, we're told that when t is equal to capital T, P is accelerating in the direction of minus I minus 27j. We need to find the value of t. So for this question, how do we find the value of t? Well, we know that it's accelerating in that direction. So if it's accelerating, we're dealing with variable acceleration here. Therefore, if we work at the velocity, we need, in terms of I and j, if we differentiate that again, that will give us the acceleration in terms of I and j. So the first thing we need to do is we need to differentiate our velocity, okay? So if we differentiate this, so we know that a is equal to going to be a dv over dt. And we know that if we differentiate this, what would we get? Well, we get a minus 3 over 4 t, and then that will be a minus 3 over 2 I. And then for this one, that cancels out nicely to a minus 3 over 4 j. Okay, so this is the acceleration now. And they tell us in the question that it's in the direction of this minus I minus 27j. It's in that direction. So what does that mean? That must mean that it must be in that scalar form. Okay, that must mean that for this question, that our minus 3 over 4 t to the minus 3 over 2i minus 3 over 4j, it must be in the same direction. It must be in the same direction as like the scalar. So let's call it lambda of a minus I minus 27j. Okay? So now, if we can figure out what lambda is, that will really help us out working what our value of t is. Okay? So in this case, we actually can work that out. We can work out what lambda is straight away, because if you look, we have a minus 3 over 4j, and that would be equal to that lambda times minus 27j. So we can work out what our lambda is straight away, because we know that minus 3 over 4j, it must equal lambda times minus 27j. So that means that minus 3 over 4 must equal the minus 27 lambda, which means that if you just work this out, our lambda value is going to be a 1 over 36. So now that we've worked out what our lambda is, okay, now we can use it to work out what our t value is. So if we look at our I values, well, we know that for our I values, if we've already worked out what our lambda value is, well then for I, it must mean that minus 3 over 4 t to the minus 3 over 2i must equal lambda, which we know is 1 over 36, times by a minus I. Okay, so therefore, what does that mean? That must mean that that minus 3 over 4 t to the minus 3 over 2 must equal a minus 1 over 36. And now we can just use that to work out what our t value is. So to work out our t value, well, if we just times both sides by a minus 4 over 3, okay, then that would be t to the minus 3 over 2 is equal to a minus 1 over 36 times by a minus 4 over 3. And therefore, that would give me that t to the minus 3 over 2 is equal to a positive 4 over 108, which cancels down to a 2 over 54, which then cancels down to a 1 over 27. So if we have that t to the power of minus 3 over 2 is equal to 1 over 27, well, therefore, we can just raise everything to the power of 2 over 3, okay? So if we do that, and that's a minus 2 over 3. So if we do that, therefore we're left with just t is equal to, well, let's get rid of the negative power first. That'll become a 27 to the power of 2 over 3. And therefore, we just need to cube root and then square. So if we, doesn't matter how you want to write it, but effectively, if we cube root first, we get a 3, then we do 3 squared. Therefore, we get a 9. So we know that t is equal to 9 seconds. So for this question, okay, we have that a small stone is projected with velocity 35 meters per second. We're told that the stone is projected at an angle alpha to the horizontal. Our tan alpha is 3 over 4. It hits the ground at point A. We're told that time t seconds, the horizontal distance of P from O is x meters, and at time t seconds, the vertical distance above the ground is y meters. So we don't exactly know where it is, but let's just say it's like around here, for example. Let's say that is P. We know that at some time t seconds, okay, we know that this distance here is going to be an x meters. We know that this distance is going to be a y meters, okay? We need to use the model to show that y is equal to 3 over 4x minus 1 over 160x squared. Okay, so I've drawn a little diagram here. So first things we can do is it's a projectile motion question. So we're going to have our horizontal component and then our vertical component. And we need to work out that at time t is seconds, you get an expression for y is equal to x. So we know that at time t, when it's time t seconds, particle p is somewhere in its motion, okay, and it's going to have a distance of x meters and a distance of y meters. So all we need to do is work out the horizontal components and the vertical components, and then our t values are going to be the exact same, and then we can put them together. We should get expressions for y and for x. So let's start with the horizontal component first, okay? So what do we know? Well, we know our s value in this case is going to be just x. Okay, our u value, well, they tell us in the question that it is projected with 35 meters per second. So we're projecting with 35 meters per second. And therefore, in these type of questions, we know that if we're doing the horizontal, because it's at an angle alpha to the horizontal, it's going to be a 35 cos alpha. And we know in this case, t would just be a t. Okay, another thing to note is we're told in the question that tan alpha is 3 over 4. Therefore, if we draw a little right angle triangle here, then this would be 3, this would be 4, that would be 5. Therefore, we know that a sine alpha is going to be a 3 over 5, and a cosine alpha is going to be a 4 over 5, okay? So if we work out this value now, we know that in the horizontal motion, where it's constant acceleration, we know that s is equal to ut. Therefore, in our case, that would be x is equal to a 35 cosine alpha times t. And we know that therefore x would equal a 35 times a 4 over 5 times a t, which therefore would give me a 35 times 4 over 5 would give me a x equal to a 28t, okay? And therefore we want an expression for t, okay? So if we just get an expression for t, we get that t is equal to an x over 28. So we know that at this point where p is, it's going to be at time of x over 28 seconds, okay? Now let's do the same thing for the vertical. So if I do the vertical down here, now vertical is very important to make sure you specify which direction you're doing, because that will change values. So in this case, for the vertical, well, we know the distance is just going to simply be this y value here. So therefore, s is equal to a y. Our u is going to be, because it's in vertical, it's now going to be a 35 sine alpha. Okay, our v we don't know. Our a, now remember, because we're going in the upwards direction as our positive, when we go upwards, our acceleration due to gravity is going to be a negative because we're going to be decelerating as we're going up. So that will be a minus 9.8. And we still have t as t. So now we can use this, solve that equation, s is equal to ut minus a half at squared, and that will give us an expression for our t value. So if we do that, we get a y is equal to a 35 sine alpha t plus a half times negative 9.8. That would be a minus 4.9 t squared. So y is equal to a 35 times, we know sine alpha is 3/5, times a t minus a 4.9 t squared. And then what does that give us? Well, 35 times by a 3/5, that gives us a 21. So y is equal to 21t minus a 4.9t squared. Now, we know that our time is going to be the same in both of this. A time is that one constant which is going to be the same in our horizontal and in our vertical. So when we did it before, we got t is equal to x over 28. Well, we can just substitute that value of t into our vertical component as well, because they'll be exactly the same time. So if we do that, we get y is equal to a 21 times by x over 28 minus a 4.9 times by x over 28 squared. And if we work that out, we hopefully should get exactly what we want. So we get a y is equal to a 21x over 28. And then we get a minus 4.9. If you do this, you get an x squared, and then you do a 28 squared, you get a 784. And therefore, if we simplify this down now, well, we get a y. Well, 21 over 28, simplify that down, both go into 7. That'll just give us a 3 over 4x, okay? And then with the other minus 4.9, well, if you're doing a calculator, you do minus 4.9 divided by 784, you will get exactly 1 over 160. And then we're just left with our x squared value. And therefore, we've shown that it equals this equation. So now for part B, okay, we want to find the length of OA. So to find the length of OA, well, it's actually fairly simple, because to find the length of OA, so we know that this value here is O, and then this value here is A. To find that length of OA, well, if you look at the displacement would still be 0, right? Because it doesn't matter how much you go up, you're going to land at the same point as O. Therefore, our displacement is just 0. So using that equation we just worked out, we just need to equal it to 0, and yeah, that will just be it. Then we can solve for B. Okay, so let's do that here. So if we look at what our equation was, well, we know our equation is from the question. So we know that it's a 3 over 4x minus 1 over 160x squared. So if we just do that here, we know that so y is equal to a 3 over 4x minus a 1 over 160x squared. And we know that y has to be 0 because y is the displacement, right? The displacement will just be 0. So we can just do 0 is equal to 3 over 4x minus 1 over 160x squared. And we can work this out. So first things first, what we can do is we can actually take a factor of x out. So by doing that, we get x in 3 over 4 minus a 1 over 160x, and that would equal our 0. And then we get 2 points. We know one of them is x equals 0, but we know that x equals 0, that just signifies the initial time when we actually start to launch it. So that's not the one we want. We want the other one. We want when 3 over 4 minus 1 over 160x is equal to 0. And if you work this out, you would get a 3 over 4 is equal to a 1 over 160x. Therefore, we can work out our x value now. Our x value will simply just be that 3 over 4 divided by 160. And if you do that, that is the same as 160 times by 3 over 4, which gives us a 120 meters. Now, we're told that using the model, the greatest height of the stone above the ground is found to be h meters, okay? We need to use the answer to A or otherwise to find the value of h. So what do we do know? Well, we know that we're dealing with a quadratic equation here, okay? We know this is a quadratic equation. We want to find the greatest height, okay? Well, with this type of question, it's a quadratic equation. It's a just a very normal quadratic graph, right? So to work out the greatest height, there's other ways we can do it. You could differentiate this and then equal it to 0, work out what your x value is. Or you can also just know that the midpoint of this quadratic graph will also give us the x value, and then we can just substitute that in to get our greatest height, okay? But for purposes' sake, let's say you didn't know that the midpoint would give you the highest point. Let's actually just differentiate this and then equal to 0 to our x value, and then we can substitute that in. So if I do that here for us, okay, so again, we have y is equal to 3 over 4x minus 1 over 160x squared. We know that dy over dx, okay, that's equal to 0. That will give us our stationary point for our x value. If we do that here, we get a dy over dx that is equal to a 3 over 4. And for this one, we do a 1 over 160 times by 2 is a 2 over 160, so that'll give us a 1 over 80, okay, and that'll just be an x, and that must equal 0. Therefore, we get a 1 over 80x, and that would equal a 3 over 4. And then if you was to work this out, you do 3 over 4 divided by 1 over 80 is the same as 3 over 4 times by 80. Therefore, we would get x as 60. And also, that is also the midpoint, right? Because we know that OA is 120 meters. The midpoint would be 60. So anyway, we work out x. Now we just plug in that value of x into the equation, and that will give us the greatest height. So if we do that, we get y is a 3 over 4 times by 60 minus a 1 over 160 times by 60 squared. Use your calculator for all of this. And then if you do that, put that onto your calculator, you would get a 45 over 2, which is 22.5 meters. So we know that vertically, the greatest height is 22.5 meters. Okay, and we've got that for part D. So now the model has air resistance, okay? And using this new model, the greatest height of the stone above the ground is found to be k meters. So we need to state which is greater, h or k, justifying our answer. So here's a question, okay? If it's now got air resistance, and we know that, and now the greatest height is found to be k meters, well, which one is higher? Well, h would still be higher, because if you have air resistance, right, air resistance is just going to slow down the stone. It's going to slow it down, so it won't reach a greater height unless there's some crazy force or some crazy, or like the speed has changed, right? Then it's just going to be slowed down, so it won't reach a greater height, okay? Because it's going to slow down along with the acceleration due to gravity. It's going to slow down at a lot faster rate, which means that it won't reach the greater height. Therefore, h would still be greater than k. So for part E, we have to state one limitation of this refined model. Now, just key, it says refined model. So it wants you to be very specific to this refined model, okay? Just a refined model. So what you want to do is, now that we've got air resistance, right? We want to think about with the air resistance, is any limitations that this air resistance or this refined model now, this air resistance doesn't take into consideration. Well, one thing we can take is any weather effects, right? Because while we've got air resistance, we don't really take any other weather effects into consideration, okay? So it's a limitation of this newly refined model, okay? Just be careful that you don't just do a limitation of like the previous model. It's related to the refined model. So now we've got air resistance. What's the limitation of this air resistance effectively? Well, now that we've got air resistance, we don't take any other weather effects into consideration. So that would be a limitation of this refined model. So question 6, we have this uniform rod here. We've got a mass m and length 2a. So straight away, I know that because they've told me that it's got a length 2a, straight away, my head is buzzing. I know that I'm probably going to have to use moments here. So we're told that the rod has its end A on rough horizontal ground. Okay, so there's going to be friction at A. It rests in equilibrium. We've got a smooth horizontal peg P. Okay, so there'll be a normal reaction there. We've got tan theta is 4/3, and yep, all this other good stuff. We show that S is the normal reaction on the peg. Show that S is 2/5 mg. So then we just draw everything I need to know down here. So one thing we have is we have a uniform rod. Okay, so we're going to have a uniform rod. So let's just draw a line coming down here for the weight. And we know that the weight is, what is the mass? The mass is just capital M. So we're going to have an mg newtons. We know that it's a angle theta to the horizontal. So we know that this is going to be a sine theta here. What else do we know? We know we have a peg P, okay? So a peg P, which means that if we just draw the peg here, okay, this is like peg P. We know that we're going to have a normal reaction at peg P. So we're going to have like a normal reaction here. So that will be, that's our S newtons actually, that'll be S. What else do you know? Oh, we have A as well. So if this is A down here, we also know that there's friction here. So we're going to have R newtons is here, okay, and we're going to have a frictional force. Now, how do we know which way the friction is going? Well, we are in equilibrium. Yep, we're told that we're in equilibrium here. So therefore, if we know what direction the frictional force goes, well, if you look at this question here, there's only one direction the frictional force can go, and that is to the right. Because remember, it has to balance out the other horizontal force. If the other horizontal force acts to the left or has a force to the left, the friction must need to balance it out. So friction is going to this right direction here. And what do we need to do for this question? Oh, we know lengths as well. So let's think about the lengths. Because it's uniform rod, we know that the weight is going to be in the midpoint. So we know that if it's a length 2a, this distance here will be a. They tell us in the question that AC is 1/5. So therefore, we know that from A to C, is that A to C is a P? Okay, so P is also C. Okay, so therefore, we know that this, from this to this is going to be a 0.5A. And this is our B value. Okay, well, not B value, it's just our B. We know that this will also just be a 0.5A as well. So now we have everything we need to work out first question. First question is show that S is equal to 205 mg. So S is our normal reaction to the peg. So therefore, we have so many unknowns, right? So ideally, we want to be able to resolve by forces, but we can't in this question because we have too many unknowns. We have R, we have F, and we have S. Therefore, what can we do? We can take moments. Okay, so if we take moment to A, take a moment to A will eliminate the R and the F for us, so we can work out what the S is. So if we take moments at A, okay, therefore, what would that look like? Well, let's start with the S newtons, the anti-clockwise moment. Well, that peg at P is already perpendicular, mind my drawing, but that normal reaction at P, that's already perpendicular to the rod, so therefore it would simply just be S, and that would be S times by the distance, in this case is 1/5A, so times by 1.5A, and that would equal the weight. So the weight, if I just draw the weight, make the weight perpendicular, okay? So the weight needs to be perpendicular to that rod, so that'll be the theta here. So therefore, for the weight, that would just be mg, and that would be a cosine theta, okay? A cosine theta, and that would be times by A. Okay, so now at this stage here. Well, now if we just, we can simplify out the A's, because they both have A, so get rid of the A. We're left with a 1.5 S is equal to an mg cosine theta. However, what is that cosine theta? Well, we're told in the question that tan theta is equal to 4/3. So if I just do that over here, okay, it's equal to 4/3. Okay, that is not a good drawing, but imagine that's a right angle here, and that is that there. We know that this would be a 4, this would be a 3, that would be a 5. So therefore, we know that a sine theta is equal to a 4/5. A cosine theta is equal to a 3/5. So therefore, when I have mg cosine theta, that is the same as saying mg times by 3/5. Therefore, we get a 1.5 S is equal to a 3 over 5 mg. And therefore, just to work out the S value now, we just need to do 3 over 5 mg divided by a 1.5, which gives you a 2 over 5 mg. And for that last question, okay, we are told that the coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, find the value of mu. Okay, so if I do that over here, part B. Okay, part B now, we need to find that value of mu. So what do we know from looking at this? Well, first things first, we know the equation for mu. It's going to be friction is equal to mu times R. So we need to work out what the friction is, and then we need to work out what the normal reaction is at A, and therefore once we know that, we can do friction divided by the normal reaction, and that will give us our mu value. So how can we work out our friction and a normal reaction? Well, let's start with the normal reaction. Okay, so with the normal reaction here, if I just get rid of, I'm just gonna get rid of all of my lines here because we don't need moments anymore. We are just going to be resolving by forces. So I'm just going to get rid of my line here, so just make it a bit more clear. So now what we need to do is we need to work out our normal reaction and our friction. So let's do normal reaction first. So if we resolve in the vertical direction, okay, that would be an R plus an S. Now, with the S, it's going to have a vertical component, okay? It's going to have some type of vertical component here. We also have a horizontal component here. So we need to work out what these values will be. Loads of ways you can do it. The way I like to do it is, we know this angle here, by just looking at it, this is like alternate angles, right? Alternate angles. That angle must also be a theta, because it's to the horizontal, right? That slope to the horizontal will always just be a theta. It doesn't matter where it is, it will always be a theta. So we know that that's going to be a theta there. And therefore, we know that because this is going to be perpendicular, we know that has to be the sine theta. Therefore, this will also just be a theta here. Okay, so we'll work that out. So we know that its vertical component is going to be a cos theta. Its horizontal will be a sine theta. So that we know that, we have everything we need. We know that if we're doing vertical direction, that will be R plus S cosine theta, okay, and that must be equal to our weight, which is mg. And we know what S is from the previous question. We know from the previous question, okay, we know that S is equal to a 2 over 5 mg. So therefore, for this question, we have that R plus 2 over 5 mg. And we know that from our previous question, a cosine theta, let me just double check, a cosine theta was 3 over 5. So let me just write that here, that a sine theta was 4 over 5 and a cosine theta was 3 over 5. We know that that must also be times by a 3 over 5, that's cosine theta, and that must equal mg. If we work this out, we get an R plus a 6 over 25 mg, and that must equal mg. So therefore, if we bring the 6 over 25 mg to the side, we get an mg minus 6 over 25 mg, which is a 25 over 25 mg minus a 6 over 25 mg. So that gives us that R. R is equal to a 19 over 25 mg. Okay, so worked out what R is. R is 19 over 25 mg. Now let's look at what F is. So our F value, if we look here, F value, we can work that out by resolving horizontally. So if we resolve horizontally, okay, then that would be so resolve horizontally, that would be an F is equal to an S. Now let's look at our S, as I've drawn already on there. The S to the horizontal is at an angle of sine theta here. Okay, therefore it would just be F is equal to S sine theta. And therefore we know what S is. So we know that SF is equal to 2 over 5 mg. And we know our sine theta is going to be a 4 over 5. Okay, so we know that that's going to be times by 4 over 5. Therefore, F is equal to 2 over 5 times 4 over 5 is 8 over 25 mg. So we worked out that F is 8/25 mg. We know that our reaction at A is 19/25 mg. Therefore, we know the equation is F is equal to mu R. So we know that, let's write it as 8 mg/25 must equal mu times 19 mg/25. Therefore, if we were to work mu out, mu would be a 8 mg/25. Okay, that would be divided by 19 over mg/25, which is the same as saying times by 25 over 19 mg. And then if you work that out, well, a lot of things cancel out. Mg's cancel out. The 25s also cancel out. Therefore, we're left with mu simply equaling 8/19. And that will be this paper done, this mechanics paper done. Yeah, I hope you enjoyed it. I'll be continuing doing mechanics papers, so the next one will be 2023. So I hope you enjoyed this, and hope you will stay tuned for that video too. But yeah, I hope you enjoyed this, and I will see you soon.